because
Okay. No, just want to tell him that just accept it when you say that I'm recording, so that you need to actually accept that too. So let's look at binomial expansion. It's part of learning outcome 1. So the best way to actually use binomial expansion is to use there's one thing they call the Pascal triangle. So this is a Pascal triangle. You can see that one. You can see the 2 ones now spread out. Then 1 plus 1 will become 2. Then you also mask it with 1 and 1. So it's just as if you are adding the 2 previous one to make the next one. So let me see, maybe I can put that one now. You can see 1. You have maxed that 1 with 1 and 1. So let me just write it out. When you see 1, you maxed it with 1 and 1. So what is 1 plus 1? That gives you 2. So then you mask it again with 1 here. So what is a 1 plus 2? That gives you actually what? That gives you 3. 2 plus 1 gives you 3. Then you also mask it with what? With 1 and 1 here. That's so you continue. But what we're going to do today will not take that long, that we have to go to 4. This is 4. You can see this one is 1 plus 3 is 4. 2 plus 3 is going to be 6 here. And then there's going to be 4 here. So you mask it again with 1 and 1. But I think we're going to stop at the 3rd power. So there's something you have to get familiar to. It's something they call notation. So you have something like this. If you have 4 days, so that gives you 4 times 3 times 2 times 1. Can you see? You can see that 4 times 3 times 2 times 1. So if you have 3, it's going to give 3. You see the notation there. That gives you what? 3 times 2 times 1. So if they ask you that what is 5 notation, just want to be sure I'm 5 notation divided by 4, you have the notation there. So that gives you, it's going to be like 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1. This we cancel this. There's going to be only 5 left. So that's actually what you do sometimes when you actually when you want to divide. So when you use binomial expansion, it's always an expression to the power. So if you have, it can give you 4 plus 5x to the power of 3, then you now use, you now expand it using what? Using binomial expansion. That is just that. So I want us to look at examples now and see exactly how it's going to actually work. You can see that one equal to the power of 0. That's the ascending order of binomial distance. So let's look at example of things like this. So sometimes if you say you should expand this, find the expansion for this for this expression of 2 plus 3x to the power of 4. The 2 plus actually 3x to the power of 4. So this is the normal, this is what you're going to expand it to form. But I'm going to actually to go through why is actually like that. So you will see that in the first one that you see here, let me just annotate this. I want to try, maybe I can use a whiteboard because that one might be, okay, let me use this. Let me do the second one for you. That one might be a bit fairly straightforward. I'm going to make it bigger, 1 sec. So that if I explain it 1 or twice, you will not need any other question again. Okay. 1 sec. No, sorry. So make it bigger on my side. So I'm going to give you access to all these things too. So as soon as we are done, they will send the recording to the email. So they will share the recording to the group. So this one, you can see the first one is this is the ascending power. Because it's 4, so it's going to be at 4, 3, 2, 1. So can you see it's going to be going down that way? The first one is going to be 4, second one is going to be 3, the third one is going to be 2, that one is going to be what? 1. Then the last one is going to be 0. Don't forget to add that one down. 4, 3, 2, 1, 0. The other power will be moving this way. 0, 1, 2, 3, and 4. So because you have what's it called? Because you have 2 coefficients there. So that is what is going to actually what? That is what's going to happen. So we're going to be using these 2 and 3x. So before I went to this, I told you about the what's it called? The Pascal triangle. I told you about the Pascal triangle that when you have 1, you will flank the 1 by this one. So 1 plus 1, that gives you 2. You flank it again with what? With 1 and 1 here. 1 plus 2 gives you 3. 2 plus 1 gives you this one, 2. You also flank it again with another 1. 1 plus 3 gives you 4. This one gives you 6. The other one gives you 4 again. And you see, you flank it again with another 1 here. So then it goes like that. You get actually what is going to actually what go like it goes like that. So you can see that one. So if you want to make it, you follow the same process all the time. So back to our solving question now. So if you can do these powers out and also do the Pascal triangle out, then your job is like nearly there. So you see, so next we have what? Ascending, descending, and ascending order. When you say descending, means that you are going down. When you say ascending, means what? It's actually what? Increasing. This one is in descending order. This one is what? Is in ascending order. You get it? Going to the power of what? Power of 0. You get it in the center of 1. And there's something you need to know is this. Anything raised to power of 0 is 1. So if you have like 3x to the power of 0 is 1. When you have like 3x to the power of 0 is what? Is 1. Anything that you raise to the power of 0 is actually what? Is 1. Please don't just be aware of that, because we don't use to the power of 0. It's part of the knowledge you might probably have acquired in indices. So let's look at the first one. In the first part of Pascal triangle, you can see we can use so it goes to the 4th power. Can you see? We stop because this one is the fourth power. So you got 1. This is 1. This is 2. This is 3. So no, this one is not part of it. 1, 2, 3. So this one is we're going to use this one. That's what you're going to use. So when you see the 1 here, that's the 1 you actually want to see here. 2 to the power of what? 2 to the power of 4. You can see that one there. 2 to the power of what? 2 to the power of 4. So there's something here that is missing. They're meant to put what here? 3x. Apologies, I didn't put that one to the power of 0. Because can you see? It's going to be 4, 0. The first set of powers will be 4, 0. So I told you earlier that anything raised to the power of 0 is 1. That's why it doesn't appear there. So that's the first one done here. The second one, can you see, is 4. So you put 4 out. you put this power is 4 on 2, so it's going to reduce by what? By 1. So it means what? 2 to the power of 3, then 3x to the power of 1. Can you see? Because this power was 0 before, that increased to what? Increased to 1. This one was 4 before, decreased to what? 1. I told you descending and actually what? Ascending order. That's actually what the power was actually what arranged. 6 is the next number there. Can you see? So 6 is going to be what? 2 to the power of 2 and 3x to the power of 2. So can you see that one is decreasing? Next one here is 4. So all the number you see here, 1, 4, 6, 4, 1, they are from the Pascal triangle. They are from the Pascal triangle. So 4, can you see this one becomes what? 1. This one is going to be what? 3x cube. Then the last one, you know, they didn't write that there was nothing here. It means what? 2 to the power of 0, because 2 to the power of 0 is 1. So the 1 we are putting here is of no importance, because 1 times 1 is 1. So the one you see here is from the Pascal triangle. 2 to the power of 0 is the power from 2, then 3x squared. So that gives you that. So then we now solve it individually. What is Ian, can you tell me, please, what is 2 to the power of 4? Can you tell me what is 2 to the power of 4?
2 to the power of 4?
Yes.
2 to the power of 4 is 16. 16,
thank you. So that's why you got the 416 there. And there's no other number times 1 and times 1. It's going to be only 16 there. What is 2 to the power of 3 times 4?
Will it be 12?
No, 2 to the power of 3 is what?
2 to the power of 3 is 8.
8, yeah. 8 times 4?
8 times 4 is 32.
32 times 3?
32 times 3 is 96.
That's why you got 96 there, then the x is there. Can you see?
Yeah.
So what is 2 squared?
2 squared is 4.
Then 3, 2 squared is 4. 4 times, this is going to be what? So that's going to be 24. So 4 times 3. So you have to square this one. So what is 3 squared?
9.
9. It's going to be 9x squared. So 9 times 4 times 6, it's going to give you this one. Don't forget, when you are squaring the 3x, you must square them separately. 3 squared is 9. X squared is going to be just x squared. So it continues like this, and goes like that. So that's the expansion for that. There's going to be, you can also do negative ones too. So let me try and show you the negative one. You can show the negative one. Negative one is just the same process with this, but just the same process. You're going to have the recording so you can have access to everything. So you can see this one to the power of 3. Because to the power of 3, we're going to stop this particle. This is what we're going to draw. We're going to do 2 here, flank it with 2. Okay, this one's going to stop at this one, 3. You see, so, and we're going to do 1. So this way we're going to stop, because it's the top, it's the third power. It's going to stop here. So the same process again, but the difference between the one we did previously and this is that you must consider negative. So when you are doing this one, it's going to be what? Minus 2x to the power of 0. Can you see? Minus 2x to the power of what? To the power of 0. So you must consider negatives there. So the reason why negative might be very important here is especially the fourth power and the third power. You know, when you square negative, it's going to be positive. But when you cube negative, it's going to be negative. And you see, that's why you see that the negative appeared in your final answer. So it's very important to just actually you take that one into consideration. There's going to be, work for you to actually do on that. I'm going to make sure that, I get those ones across to you, so that you can practice and test your knowledge to see how well you have actually progress. I would have loved you to try one for me now, but you know, when you try one, then just try and pause the video, then check the video again to see maybe you actually what, right? Because you're gonna have access to it. So if you have any question, any query, you can just direct your query to me straight off. Then I'll be more than happy to answer any query you actually would have. So, you know, that's just about binomial expansion. Then we look at how to factorize. You know, how to factorize is and what's it called? How to factorize is also very, very important. We look at how to factorize quadratics and how to factorize single brackets. So in that one, I'm going to use a whiteboard to teach you that, because I expect that if you can understand this one, that one should not be a problem for you. So let's what I'm going to do, and let me stop the share for this one. Then let me use a whiteboard for that. So we'll use a whiteboard. It's just about factorizing. So factorization. So when you want to factorize, it's like you, for a simple expression, if you want to factorize, you are finding the mode what the lowest common multiple, the highest common factor, between them. If you have something like 4x squared plus 6x, 6x. Can you see, if you look at the first part now, you can see that this one is 4. This one is like 2 times 2 times x times x. Why this one is like 2 times 3 times x. Can you see?
Couldn't you also factorize it as 2x bracket 2?
Yeah. That's why I think you're fine. So can you see now? If for me going through this one straight away, it's just too elementary. That's why I think so. So what I'm going to do basically is this. I just want to go over the process to see maybe you don't understand it before. But I think since you get it now, I'm going to give you like just 2 questions to do. I'm going to pause the video, then I'm going to pause the recording, then I will just get back to you. Maybe you get it right. So I'm going to give you 2 questions to do on that, because I think that it should not be a problem for you to understand. So look at this one. What is 4 squared y minus 24 y squared? Factorize that. Then the second one, factorize 3x squared minus 9. I'm going to pause the recording, then do it quickly in like, just do it quickly.
Yeah.
So look at it. Let's go at the next stage now.
Mm.
If you have this, come on, whiteboard, right. If you have x squared, so there's something they call the difference of 2 squares. So if you have a squared minus b squared, they ask you to actually what? Factorize it. So this is the formula. It's going to be what? A minus b Then you also have what? A plus B. Can you see? A minus B, A plus B. That is it. That's it. Can you see? They call it what? Difference of two squares. Because this A squared is a square. This B2 is also a square, you know? So, and the negative there means difference between. So when you say A squared minus B squared, it means what? Difference between two squares.
Yeah.
So if you have this example now for it, if you have like x squared minus 9, so that gives you x minus 3. Can you see?
Yeah,
Because
and then
you can turn this one to 3 squared.
would you
So
put x plus 3?
Yes, plus 3. Thank you. So that is it. So you can see that one. That's the difference of two squares. So you can try this one for me. So there's another example. Let me just give you that so that you won't get confused. If you have 2x squared minus 50. Can you see? 2x squared minus 50. You know that if you want to factorize it first, it's going to be 2. 2 is common from both sides. 2x squared minus 25. You know that? Can you see that x squared minus 25 is a difference of two squares? So because 5 squared is 25. So you can now take this one further down to what? So x minus 5 and what? X plus 5. So then you put it 2 outside. Yeah.
Yeah.
So
but then wouldn't you times the 5 by 2? Because the 2 outside the first bracket.
No,
Wouldn't
it's,
you do...
the 2 is affecting both two brackets. Because don't forget that the two brackets were together. It's not when I took the 2 out.
So you do 2 times x, which would be 2x.
And you don't need to times it just to factorize. We're factorizing. So this is the answer now. We are factorizing. So it stays like this. So the one you are trying to do is to expand. Don't expand. We are just factorizing. It's okay. We want to make it simply for factorize it. So the final example is going to be this. If you have 4x squared minus 9y squared. Can you see? Both 4 and 9, they're also square numbers. So you can put it there. It's only like 2 squared, x squared, minus 3 squared, y squared. So you put it that way. This one is going to be what? 2x minus 3y, 2x plus 3y. Can you see? That's it. So, you don't need to write these things down because you're going to have the recording. Then it's going to actually be available to you. You can make notes when you actually doing it. So, but I want you to try just 3 questions for me on this one, factorizing this. So I believe that if you have any other question, you can let me know. You can contact me if you have more questions, because the time is already fast spent, and I want to still touch on something about factorizing quadratics. Because if you have like x squared, if you have because there's a meeting coming up very soon, so I'm not really sure. Maybe the meeting will just start all of a sudden. So if you have x squared plus 5x plus 6. So this is called a quadratic expression. This is called a quadratic expression. So this is what you do. What can you multiply to get 6? and when you add them together, you will get 5. Can you tell me?
2 and 3.
Number 2 and 3. So it's going to be what?
We did this in school. So then you write them
Yeah.
both, and then you times them.
Yeah. So it's part of your learning outcome. So that's why I just have to just touch on it, So that is it. So can I just give you can you try this one for me? If you don't mind, I'm going to pause the recording. X squared minus X minus 20. Can you do that one? I'm going to pause the recording now so that you can give you time to do it. So let me just try and rub what you wrote down here. So you circle it. What can you multiply to get minus 20? And when you add them together, it's going to be what? Minus 1. So it's going to be what? Minus 5 times 4 gives you what? Minus 20.
Oh.
Minus 5 plus 4 gives you what? Minus 1, is not? So
Yeah.
minus 1. So it's going to be X minus 5 X plus 4. That's all. That's all. So can you see what can you multiply to get minus 20? And when you add them together, you're going to get what? Minus 1. So I'm going to click now and just ask you to do 1. What about this one? X squared minus 3x minus 24. So no, let me just put it this way. I meant to just make it easy for you. I'm going to cross that one out and put minus 2 there. So stop the recording again so that I can give you time to write. Yeah. So, just to check your answer when you stop here, when you say, can you see that you done now? But what is plus 6 minus 4? Let's go with plus 2. Is it not?
Oh, it's the wrong way around. It would be minus 6
minus
and
6
plus 4.
That's it. It's okay. It's got to be minus 6 plus 4. So that's just the other way around. Yeah. So I'm happy that you were able to spot that in yourself. So, yeah. So what about this one? X squared plus 5x minus 24. If I press OK now, the whole thing will go away. But let me see, because I cannot write on the screen now until I press OK. Let me see, maybe I can write. I can't write again. Okay, it has been signed in. So if I press OK now, so the meeting might end if I press OK. But you have the recordings available for yesterday and the one also available for today. Is it okay?
Yeah, where can I find the recording for yesterday?
I think it's the admin should send it to you because it's going to go to the email. Hello?
Yeah, hello.
Yeah, sorry. I think sorry. The Aman is here. Hello, Aman?